Science in the AM. I'm your host, Joel Shadaka. We just are going over, and we've already talked about a little bit moles of gas. The fact that STP, standard temperature and pressure, is 0 degrees in regular atmospheric pressure, about 100 kilopascals. And a mole of any gas, it doesn't matter what type of gas, it's always 22.4 liters of space, of volume. We're going to go through some conversion examples, and they're repetitive calculations. So, how much volume do the following gases occupy at STP? When I hear how much volume, you're thinking liters. How many liters? So, that's down here. Automatically, we know this is the fact that we're going to use here, because we're always going to assume STP, even if I misstate it, we're going to just assume it. It would be different at different temperatures. What happens, by the way, when a gas gets warmer? What happens to the space, the volume? It expands. So you see, this would actually, the temperature actually does make a big difference. Anyway, and I think you intuitively understand that. So we're using the same math skill as before. What's on the top? Want to get rid of it, goes on to the bottom. So I want mole on the bottom. What do I want to keep? How much volume? Volume is measured in liters. Now, the fact that we're using is 22.4 liters is the space occupied by a mole of gas. So, that's it. I'm going to just group this because I'm going to reuse that. Okay. Now, you're going to use your calculator. And that's multiplying because they're both on the top, right? So 1 point, I can't do that very quickly. So I get 30.24, but we're talking sig figs. I'm going to write this and then erase. This is my calculator. According to my sig figs, though, I've got 3 sig figs, 1.35, and I've got 22.4. That's 3 significant figures. Significant figures. So I need to round to 3 digits, not decimal places. 30.2. Like before, I need the units. Moles are gone, liters, and it's the chemical oxygen. Okay? That's what we need. The other two, because they're both starting with moles, it's going to be the exact same fraction beside it when you multiply. Okay? So I'm going to do 2a, and I rip through this kind of fast. If you need that. 2a, convert the following volumes, so liters, of gas of 2 moles. It's the same fact you're using, but we use the units to decide which way we do things, whether we multiply or divide. There's no formulas needed, as long as you have the correct units, which ones you want to get rid of. So I say, I've got liters on the top, 0.50 liters. I want to get rid of liters, so I'm going to put L on the bottom. I want to keep, what you want to keep is put on the top, moles. And we know the fact that 1 mole is 22.4. That 22.4 is something that you might actually have memorized, but you don't need to. If you use it the same number all the time, so you probably will have it. This means divide. This one I can do. But you go 0.5 divided by 22.4, and it should double it. Or just saying it, no, it doesn't. Sorry, I can't do it. I was multiplying in my head. I don't know. I was doing the denominator. Anyways, back to this. 0, 2, 2. That's it. I only need 2 significant digits. Front zeros never count as significant digits, or significant digits. And my unit in this case is mole, because we're supposed to convert gas to mole. And it's the helium gas. I want to pause the video, but I want you guys to do the other 4 questions because we will check up in a couple of minutes. shouldn't take you long. Okay, we'll take these up. So these three are the same. So I'm going to just reuse this again and again. Okay, they all get set up like this. So that means every time you just multiply by 22.4. So I'll just quickly ram through the 0.75 times 22.4. Boom. 16.8. Now I can't write down 16.8 because I only want two significant digits, so 17. And that's moles gone, liters of nitrogen gas. Decimal 0035, so only two significant digits. 0.0784 is what I got, so I'm going to keep two digits, 0.78, 078. Now, cool? Hey, that's not cool. Okay. These ones, once again, it's a repetitive calculation. Maybe. I just noticed you guys can direct them. You think? Okay, the second one. I get 0.15625. You guys are going to stop me if I make a mistake or have something different. This is the time to ask, right? But I do make mistakes. This has three digits in 2.50. Back zeros are important. 22.4. So I'm going to keep 0.15625. I'm going to cut it off at 0.156. Proper rounding because the next number is 2. Liters are gone. We've got moles of argon gas. You ever heard of argon gas? I think, I'm trying to remember here, on really nice new windows, they sometimes I think put argon gas in between them. And for a heat conduction reason, I think. Okay, the next one, 0.0296. So three significant digits divided by 22.4. 0.0013214286. So I'm going to cut it off with three digits. 132. Liters are gone. Moles. Carbon monoxide. This could have been, if you have a calculator that does this, 1.32 times 10 to the minus 3. This is, I still, myself, I try to write double zero instead of the scientific notation, but same thing. Okay. Now, so these, and we're going to actually go back a little bit, not just liters and moles. We're going to also have moles and particles or grams. Right. And when I say two steps, it's because there's going to be two brackets. Your general, okay, we'll go through this first example. We're going to do by doing. How many liters? How many liters for 23.2 grams of CO2 occupy an STP? So, I'm going to start by writing down the single item that's not a fraction. 23.2 grams of CO2. And it has to be a gas if we're going to use liters. It doesn't work with solids or liquids. That's only STP for gas. Now, this first bracket, though, doesn't use the 22.4. How do I decide what to do? I look. I've got grams, and I want to get rid of grams. So what do you want to get rid of? Put it on the bottom. grams. And I say, and generally all these questions were like this. Find moles with the first bracket to get your final answer, and then get your final answer. So, what do I want to get rid of? Grams. What do I want to keep? Moles. Your first bracket will always have moles. So 1 mole is, oh, rats. I've got to look up C plus O plus O, CO2. So 12.01, I just added on my calculator. 1 carbon plus 2 groups of 16, that's 32. That's the oxygen, that's 16 times 2, 44.01. This is the skill from the other day. Now, if I stop, and it's a 2-step conversion, I'm not stopping. But if I stop right now, you gotta ask yourself, if I stop right now, I would have moles of CO2. We're not going to stop there. Okay? So I'm going to actually do the cross out, just to keep in mind. Now, I'm going to use another color just so that you can see that the second bracket, the 2-step part, is clearly identified. So what do I want to get rid of with the second bracket? I want to get rid of moles. So I cancel that out. And I want to keep how many liters. So I want liters, and this is a gas. So I know it's 22.4 liters for 1 mole. Now, unit-wise, you see what happens? Top, bottom, grams, grams, moles, moles. Canceled out. You're left with liters. On your calculator, that means multiply any number on the top is a multiple. Anything on the bottom is a divide. So I'm going to go with 23.2 divide by the 44.01. If you want to go multiply by 1 first. Times the blue bracket is on the top, 22.4. Just enter it as 1 step. 11 points. 3 significant digits. Yep, 11.8 liters of count CO2. Stop. Take a look. All of these will have brackets, but your first step for the problems I give you will be to find moles with the first bracket every time. So using all the skills we've had before. Okay? And you'll always have a periodic table. Every test, I will tell you that there's 22.4 liters of gas per mole at S2. I will also tell you that for the second question, for example, we got molecules or particles or ions and stuff like this. I will tell you that there's 6.02 mole. So you won't have to memorize that either, but you do have to mathematically know what to do. So here I go. I'm going to start this second one. Find the volume of that 2.5 times 10 to the 26. Okay. I'm going to write that down because it's my single item, 2.50 times 10 to the 26. There's no abbreviation for molecules, so we're going to just use molect argon, count. And the flat fraction. And I ask myself, what do I want to get rid of? Molecules, molect, molecule. And we always want to get 1 mole, what I want to keep on the top. That's the first bracket, always has mole on the top. Then I say, there's 6.02 times 10 to the 23. You're going to use your EXP value. The molecules are gone. If I stop, I'll just wait for you to catch up. If I stop calculating right now, I would have moles of argon, and we've done that kind of thing. But I don't want to stop here. I want volume. Volume is measured in liters. It's a gas, so I'm going to use 22.4. So, what do I want to get rid of? I'm going to get rid of moles. And I know that there's 1 mole for 22.4 liters. What I want to keep is always on the front. So, this will be 2.5 10 to the 26. I write that down. My EXP or EE button, whatever your calculator down. And I I'm going to divide by the 6.02, but then I'm going to multiply by 22, because it's on. We should verify these things too. I get 9,302 and some decimals, but I only need 3 significant digits. I'm going to write this down and show you what I got. 9302.32558. I don't need all those digits. I only need 3 significant digits. 1, 2, 3. That means I got to chop it off there. Now, that means at 0 spot is, but it's still 9,300. I've got to say I'm going to keep 93, 0, and it doesn't round up, and then 0. Here's the thing, though. That's ambiguous. Ambiguous means, I'm not sure. Is that 2, 3, or 4 significant digits? Those behind zeros, because they're not behind a decimal. So if I want to be really certain, now I will accept 9,300, but if I want to show it properly, I would say this is the scientific notation way, and scientific notation only shows times 10 to the, that's 1, 2, 3. It's in the thousands, and it's the thousands. And that is liters of argon. So if you put 9,300, I'll be lenient on this one. That's the proper round. Now, remember, I make mistakes, so verify my work. Oh, I'm going to zip it up a bit. So, here we go. Like I said, I might. Did you use 10 to the 26 then? This is maybe where. I bet you use 10 to the 23. That's out of 5,000. Did you? No, is that what it is? Yeah. I'll take a look. I'll pause the video and just take a look. Maybe I'm in. Okay, no dispute there. It is 9,300. Okay. Find the mass. Okay, we start with the single item that's not a fraction. 15.5 liters of carbon monoxide. I want to get rid of liters, so I put it on the bottom. I always want my first bracket to give me moles. So 1 mole, 22.4 liters because it's a gas. I want mass. Mass is grams. In chemistry, we use grams. So that means, okay, I've gotten rid of the liters. I want to keep grams. So I'm going to have grams on the top, but I want to get rid of the moles. My second step. 1 mole is, well, C plus, 16 plus 12.01. So 2801. I'm doing this in my head, so you guys call me out if I make a mistake. Now I've gotten rid of moles. You know how to do this. Anything on the bottom is divided. Try it out. 15.5 divide 22.4 times 28.01. How much got me? Okay, I get 19.3819 so on. But my smallest amount of significant digits is 3. So I'm going to cut it off at 19.38. I'm going to call it 19.4, proper round. That is in grams, and it's carbon monoxide. Now, I am very, and I've told you this before, very sticky about this. You must show your work with flat fractions. You must show your units. Your units must be in your final answer. writing down the number, you're not getting it. One last, and then I'm going to get you guys to try these. Find the volume. Okay. But I'm giving grams at the start. 15.5. I use the same number on purpose. CO2 is the gas. So what do I want to get rid of? Grams. Put it on the bottom. What do I want to keep at the first bracket? Moles. So I'm getting rid of grams, but I have to add up CO2. So I think we just did this one. Isn't it 4401, I think? 44? Yeah. So at this point, if I stopped, I'd have moles of carbon dioxide. But I don't want to stop there. I want volumes. That's liters. So what do I want to get rid of is moles. And what do I want to keep is liters. And I know it's 22 liters. And I know it's liters because it's volume. Word match. Once again, tops and bottoms divides and moles. 15.5 divided by 44.0. 22. Now I need 3 digits in my answer, and I got 7.889. I'm chopping it off there because I need to only go to 7.88, but I can't keep that. I need to round it up. 7.89. That is liters of CO2 gas. All right. I have 4 questions for you to do. Following gas, they're gases, so you're going to be using 22 possibly. You're given grams in the second one, you're given liters in the first one. You want to get to grams. First one, you want to go from grams to liters in the second. So do those right now. Look at these split. We'll take them up in class before we leave. Okay. So, going over these answers. You got liters on the 1A and B. They're both starting off the same way. By getting rid of liters, put it on the bottom. At that point, I'd have moles of N2. I want to get mass, so I'm going to put the grams on the top, get rid of the moles. On the bottom, moles. The grams, N2 is what, 1401? Times 2, so 2802. That's how that one is. I'll calculate it. I'll write it down. Okay, I'm going to round off to 3 digits. 1.526, 1.5. Did you get that? Awesome. Is it okay that I said your name on a video? It's going to be posted. Okay, because I'll get rid of it. Okay. Same startup on this, so I'm going to just clone this. And the second one, radon. All right. 2222. Okay. 1 mole. Units cancel. I get grams. .09, but I'm going to round it to 3, so 12.1. I'm trusting some people here to correct me if I make mistakes. Maddie, I trust you, so you're just up front too. Like I trust other people. She's super close. That's the same. So, grams, O2. So I want to get moles in the first bracket, so I put moles on the top. Grams is 16 times 2, so 32 grams of oxygen. and I want to keep volume, so 22.4. I'm not changing color, I guess. One more in a hurry. And 16 divided by 32 times 22.4. Could have done some of that. 11.2 liters of oxygen. And I know that you would stop me if I did it wrong, right? Helium. I want to keep moles. I want to get rid of grams. So helium is, and I look it up, 400. I want to keep liters, so I'll put it on the top. 1 mole. 1 mole. Infinitely correct. Okay. So 16 divided by 4 is 4. I don't need to enter that on. Put 22.4. 89 points. 3 digits, that's good. I've got liters of helium gas. Okay, that's it. On Monday, we will do a bunch of practice work. Okay? Have a great weekend.